In this talk, we present a corpus study of pitch range in Japanese, specifically by looking at the influence of gender and register on F0. We try to answer the question of how prosody contributes to formality or informality in Japanese. The way pitch patterns are realized both lexically and in the intonation depends on language-specific properties. What this means is that the phonological properties of a language restrict the inventory of intonational tones that speakers can use. Typically, what was observed in previous studies is that tonal languages like Chinese make a narrower use of pitch range than non-tonal languages. If we look at the phonological properties of Japanese, what we can postulate is that the domain of pitch range variations in Japanese should be restricted. Indeed, Japanese has a lexical pitch accent. As illustrated in the example here, pitch accent is the property of a given word, so that kaki ga persimmon, kaki ga oyster, and kaki ga fence are contrastive. Thus, a reduction of the domain of pitch range variation should occur in order to prevent the loss of this contrast. What we are saying here is not that Japanese doesn't use intonation, but that, compared to other languages in which there is no tone or pitch accent, the range of F0 is narrower. We can find other hints that intonation is reduced in Japanese, for example in the use of the interrogative particle ka, which might replace a rising intonation in questions, and in general, the cultural rules against the display of social effects among the Japanese. Previous studies on pitch range in Japanese show that it's narrower when compared to other languages like English, for example, but that it can be modulated in specific pragmatic situations. For example, findings from infant-directed speech show that when talking to infants, speakers' F0 range is wider than when they talk with adults. Corpus studies on Japanese also show the importance of several factors in the prediction of F0 range variations. Our results in a previous study suggested the importance of gender and register in F0 range variations. In particular, we found that male speakers had a wider pitch range than female speakers, an observation in contradiction with the widespread intuition as well as the literature on women's speech that indicates they have a wider pitch range in English, for example. We also found that F0 range had an influence on the impression given by the speech to listeners in terms of formality, fluency, naturalness, and confidence, among others. So, in this study, we had two goals. The first was to investigate the nature of the difference in pitch range observed between male and female speakers. Secondly, we wanted to define better how F0 is related to formality in Japanese. For this study, we used the corpus of spontaneous Japanese. We specifically used the CSJ core, a subset of the corpus composed of 201 speech samples. The CSJ core comes with a variety of annotations such as speaker and speech information and comprehensively annotated text grids. It's also divided into 4 different speech styles: dialogue, a dialogue between 2 speakers; academic presentation speech, a conference presentation; simulated public speaking, where speakers have to make a speech about a given topic without an audience; and reading, a reading task. In order to measure pitch range, we used the utterance, which is called the transcription unit in Mike Howard's work, as the unit of measurement. It is defined as an utterance separated from the next one by a 200 millisecond pause. We extracted the data automatically from the text grid file using a prod script. We especially extracted F0 mean, F0 minimum, F0 maximum, and F0 range in both hertz and semitone. For the analysis, we used the semitone scale. which is the proportional scale, in order to normalize the data and therefore avoid dealing with the inherent differences in male and female voices that we find in F0 values. We checked the data manually to exclude errors and conducted statistical testing with R.
Let's now look at the results. First, we investigated pitch and gender. In the present data, we found similar results to what we observed in our previous study. Male speakers have a significantly wider mean F0 range than female speakers. This is illustrated in the box plot on the right, where we can observe both a higher mean F0 range and a wider F0 range distribution for male speakers in the right box. This is again in contradiction with the view that female speakers show more F0 variations. Now, if we look at the distribution of minimum, maximum, and mean F0 values, that you can see in the box plot on the right of the slide and in the table, what we observe is as follows. First, although female speakers have higher F0 values, their pitch range is narrower. Second, the wider pitch range for male speakers seems to be due to their lower minimal F0 values. Now let's turn to the influence of register on pitch values. In the line graph on the right, we represented the mean F0 range values by register R, A, S, D, this is the formality order, for male speakers, the dotted line, and female speakers, the solid line. What this data tells us is that the general tendency for both male and female speakers is that F0 range goes down with formality. That is, the less formal the register is, the wider the F0 range. This was shown to be significant by statistical testing. Now, if we look at speaker groups separately, we observe different tendencies. First, the testing of the data with Tukey's methods indicated a significant difference between all four registers. On the other hand, for male speakers, the same testing indicated that only D dialogue is different from the other styles. This difference can be interpreted as a difference in sensibility of the two speaker groups. Male speakers are more sensitive to the referential function, the degree of formality, while female speakers are more sensitive to the affective function of speech, like the presence or absence of an audience or the degree of closeness with the audience. If we turn now to the mean, minimum, and maximum F0 values for female and male speakers that we can see in the line graph on the right, we can see a significant effect of talk style on minimum and maximum F0 values. Specifically, we observed that F0 minimum goes down when formality increases, which causes the range to be wider. For male speakers again, the effect of talk style was significant for both minimum and maximum F0. What is especially of interest here is that maximum F0 values for male speakers are close to those of female speakers, while F0 minimum is clearly lower. This accounts for the wideness of pitch range in dialogue for men. So what our results suggest here is that in order to express a lesser degree of formality in Japanese, both female and male speakers exhibit similar behaviors. They raise their F0 and they use a wider F0 range. To summarize our findings in this study, we found that when looking at the influence of gender on pitch, male speakers' F0 range was wider than females. We also found that F0 range was wider in general for male speakers because they have lower F0 minimum values. For pitch and register, we confirmed a difference in sensitivity that associates male speakers with the referential function of speech, while female speakers are more sensitive to the affective function. More importantly, it appears that informal speech in Japanese is characterized by a higher F0 and a wider F0 range, while formal speech has a lower F0 and a narrower F0 range. This will be developed further in the discussion. First, we would like to discuss the perceptual gap that was observed between our impression that female speakers make a wider use of F0 than male speakers, and our actual results that male have a wider pitch range. In fact, such a discrepancy between perceived pitch variation and its physical reality is not uncommon. For example, this is the case in a wide body of research on autism spectrum disorder. In the present case, we postulate that this discrepancy may be originated in female speakers' tendency to speak using a higher F0 register when compared to male speakers. A second point we would like to discuss is how F0 is used in Japanese to express formality. There is a theory of the frequency codes which proposes that a higher F0 is a universal indicator of a more formal and differential speech. Our results here are in contradiction with the theory, and this is also the case in previous studies on Japanese, which produced mixed results or results similar to what we found here. If we take a closer look at the nature of the Japanese language, this can, however, be explained. As we mentioned before, Japanese has pitch accents, and as such, a narrower pitch range is expected in order to maintain contrasts. If we consider that maintaining canonical forms, both segmentally and prosodically, is a property of formal speech, then it is not surprising to observe a narrower pitch range in a formal situation, speakers being more sensitive to the correctness of speech. On the other hand, in Japanese, informal speech is associated with a variety of reduction processes at both the segmental and syntactic levels, which may therefore allow more deviations from the norm. These results are to be put in perspective with a study on Korean, where the authors propose that the cross-linguistic association between a higher pitch and politeness might not be relevant in languages that make use of honorifics in specific formal contexts as a form of social indexing. This is the case of Korean and also of Japanese, suggesting that the similar results observed in both languages are due to the specific nature of formality in these languages. Thank you for your attention.